Suppose we have a normally distributed random variable with a population mean of 20 and a standard deviation of 1.5. And we are asked to find the probability that a randomly selected value would be between 17.4 and 23.6. We should begin by drawing a picture of the distribution and indicate that the mean is 20 and the standard deviation is 1.5. Then locate these values on the curve. We have 17.4, which will be to the left of this mean of 20, and we have 23.6 to the right. We're asked to find the probability that a randomly selected data value would lie between these values. So we should shade the area that we're looking for then, which would be between, and then calculate z-scores. Remember that the formula for z is x minus mu over sigma. So for the first endpoint, 17.4, z would be 17.4 minus 20 divided by 1.5, which would give us minus 1.73 when we round to 2 decimal places. For the second one, we'd have z equals 23.6 minus 20 divided by 1.5, which would give us 2.40. So we'll need to find this area that is shaded to the left of the mean and this area that is shaded to the right using these two z values, and we can use StatCrunch to do that very easily. We'll click Stat, Calculators, Normal, and this normal probability calculator will appear. Notice that it is already standardized with a mean of 0 and a standard deviation of 1. What we'll do then is type our z values in here. The first one will be minus 1.73. And then we'll make sure that this says greater than. Now, this area that is shaded is given in this last box, 0.9581884. But that's not what we're looking for. We're looking for the portion of this that is between a z-value of minus 1.73 and the mean here. So what we would have to do then is subtract 0.5, because half of the distribution would be to the right. So this area is too large by 0.5. So this area in here will be 0.9582 minus 0.5, which gives us 0.4582. Now to find this area in here, we'll go back to the calculator and use this 2.40 z-value. So we change the minus 1.73 to 2.40. Make it less than, because we're looking to the left now. And we have the same situation. This calculator, the way it works is it calculates everything to the left or to the right of a value. So this now is too big by 0.5, 0.9918. So we take 0.9918 and subtract 0.5 from it, and we wind up with 0.4918. So this area to the left is 0.4582. This area to the right is 0.4918. So this total probability then will be the sum of those two values, 0.4582 plus 0.4918, which then gives us an area or a probability of 0.9500, when we round to 4 decimal places.